Welcome to another podcast. In this episode, we're going to be taking a look at another trigonometric substitution. I want to take a look at the integral of dx over x squared minus 9. Now, if you've watched previous videos, then you should be familiar with the substitution that we're going to try to do here. Because the radical is of the form x squared minus a squared, where a is 3, then the appropriate substitution to make here is 3 secant theta. In which case, the differential of that is 3 times the derivative of secant. The derivative of secant is secant tangent d theta. So just a couple of little things to remember there. Now, if you recall, all of these things come from triangles, right? So let's look at the triangle for this problem quickly. We'll bring it up again later in the solution, but I just want to go ahead and take a look at it with you to start. This particular substitution comes from a triangle that looks like this. This is how the radical x squared minus a squared results. And so the question that I have is, if you plug x back into, so if I plug this 3 secant theta back into the radical, what does it turn out to be? Well, without going through the algebra, we can actually answer that using the triangle itself. See, according to the triangle, what happens is, if you take this radical, then the tangent of this angle is the radical over the value a, which suggests that a tangent theta is the radical x squared minus a squared. So what that says is, when you do this substitution, x equal 3 secant theta, the result is the radical itself can be replaced with tangent. Now, just to show you that that is indeed true, look what happens if I take 3 secant theta and plug it into the radical for this problem. Then what we get is the square root of x squared minus 9. I'm going to take and plug in 3 secant theta. So I'm just taking x and plugging it in here for the radical. This is the same thing as the square root of 9 secant squared theta minus 9, which if you pull out the 9's, they come out as a 3. And you're left with secant squared theta minus 1. And our Pythagorean identity says that that's tangent squared theta. And the square root of tangent squared is tangent. And so the point that I want to make is, by substituting in x equals 3 secant theta, we create this pairing of this with this triangle, and in doing so we create this pairing of the radical with 3 tangent theta. And so you don't want to have to always plug in these values, and so it's probably worth your time to sit here and think, okay, if I make a tangent substitution, then associated with that tangent substitution, when I look at the radical, is the result 3 tangent theta. That'll make your substitutions a little bit more efficient. So if I'm looking at this integral now and I want to go ahead and evaluate it, let's plug everything in. The integral of dx for this problem is 3 secant theta tangent theta d theta. And x squared is going to be 3 secant theta quantity squared. And then the radical, we just went through describing that I can replace the radical with 3 tangent theta. All right, let's do a little bit of simplification here. The bottom becomes, 9 secant squared theta times 3 tangent theta. We should be able to make some cancellations at this point. In fact, a lot of cancellations at this point. And that leaves us with a 9 in the bottom, so I'm going to bring that outside the integral, and a 1 over secant theta left for my integral. Well, if you remember, secant theta is the reciprocal of cosine. So because of that, this is the same thing as 1/9 integral cosine theta, which is very easy to integrate, unlike the last example, which had the integral of secant. This one's fairly easy to integrate. The integral of cosine is sine. So we've got sine of theta plus a constant. And so only thing we need to decide now is, based on this triangle, what is the sine of theta? Well, if you look, remember the sine of theta is opposite over hypotenuse. And based on this triangle, the opposite side is x squared minus a squared. It's this radical. So for this problem, it's x squared minus 9 over the hypotenuse, which is x. And so that's how we finish out the problem. We're going to substitute in the algebraic expression x squared minus 9 under the radical over x in for the sine of theta. And so our final answer at this point is given to us by this expression. Now, these are pretty long problems. They can get really complicated. There's a lot of steps involved. There's a lot of trig identities involved. I think the best way of handling this for most students is to make a little table that says, if this is your radical, then this is your substitution. And then if you make that substitution, this is what the radical in the problem turns into. So for this example, the radical is x squared minus a squared. The substitution is a secant theta, and the result of plugging it in is a tangent theta. So if you just get in the habit of thinking like that, that's going to greatly reduce the frustration on these problems. Remember, the tests are open book, open note, and so you're going to be able to refer back to these substitutions to figure out which ones to make. And so, basically just focus on the process here. Understand where these substitutions are coming from. That's important to me, is that you understand where the substitutions are coming from. That they result from this triangle, and that you can use the triangle to also re-express the radical. All right, thank you for watching.